picture the tarmac at Teterboro right now,
Hmm.
or, Farnborough. It's early 2026.
Right.
And the hardware sitting on the ramp, it really hasn't changed much in the last 5 years.
Not at all.
You still have your Gulfstreams, your
Yeah.
Bombardiers, the same sleek aluminum tubes. But, and this is where it gets interesting, if you look at the fuel receipts for those exact aircraft, you will see this massive economic anomaly.
It's staggering when you actually see the numbers.
Yeah, because a significant portion of these owners are voluntarily paying 3, maybe even 5 times the market rate for fuel just to fly the exact same routes they flew a decade ago.
Exactly.
And we aren't talking about a marginal increase for some premium additive here.
No.
We're talking about a 300 to 500% markup, which is wild.
Yeah.
Because in literally any other sector, that kind of voluntary cost absorption would be considered totally irrational behavior.
Oh, absolutely.
So the question we need to answer today in this deep dive is simply why? Why is the most capital-conscious demographic on the planet suddenly treating jet fuel like it's a rare vintage wine?
It does look like irrational market behavior on the surface, doesn't it?
It really does.
But if you dig into the reports we have today, which is our mission here, it becomes pretty clear that this is actually a calculated survival strategy.
A survival strategy?
Yeah. They aren't paying for performance. They're paying for viability. We are watching the entire concept of luxury undergo a complete structural overhaul right now.
Okay, so it's not about the leather seats or the onboard champagne anymore.
No, it's about guilt-free access.
Guilt-free. That phrase usually implies, marketing fluff. But here we are actually talking about the hard mechanics of aviation.
We are?
Because the sources we're looking at today suggest that private aviation is pivoting incredibly hard towards sustainable aviation fuel, or SAF.
Right, SAF.
And it seems like this isn't just a nice to have anymore, it's really becoming the operating system for the entire industry.
Exactly. This isn't just a trend, it's a fundamental transition. And to really understand it, for you listening, we have to look at 3 distinct pressures that are converging right now in 2026.
Okay, what are they?
First, the engineering reality. Second, those massive economic premiums we just mentioned. And third, which is fascinating, the infrastructure strong-arming that is quietly forcing this whole change.
Okay, I want to get into the strong-arming for sure, but let's start with the sociological aspect.
Sure.
Because the status symbol argument usually feels a bit abstract,
Yeah.
but the sources here are quite specific. They argue that in high-net-worth circles, the flex has completely shifted.
It really has. I mean, think about the evolution of luxury signaling over the years.
Right.
In the 90s and the 2000s, the jet itself was the signal. It was all about size, range, speed.
The biggest plane.
Exactly. But in 2026, simply owning a jet carries a genuine reputational liability.
Yeah, that carbon shaming we saw starting in the early 2020s.
Right. It solidified. It went from a Twitter hashtag to a genuine social and corporate risk.
Yeah.
So the new status symbol isn't the jet. It's the cleanliness of the operation.
It's basically a defensive play.
In part, yes.
Yeah.
But it's also highly competitive.
How so?
Well, if you are a CEO or a high-profile individual, you want to be able to step off that plane and say, I flew here, but my footprint is net zero.
Ah, I see.
And it separates the old money approach, which is increasingly seen as wasteful, frankly, and out of touch, from the modern elite approach. The modern elite frames itself as responsible, forward-thinking.
That makes total sense. It's like the difference between wearing a massive fur coat in 1980 versus doing it today.
Exactly. One was pure status. The other just puts a target on your back.
Right. But let's get into the how, because this is where the skepticism usually kicks in for people who follow this space.
Oh, for sure.
We hear sustainable aviation fuel, we hear the term drop-in solution, and honestly, it sounds a little too convenient.
It does sound like a magic bullet,
Yeah.
but the chemistry actually backs it up entirely.
Really? Because when we say drop-in, I assume that means you can just swap it.
We mean it in the literal sense. You can take SAF, mix it with conventional Jet A or Jet A1 fossil fuel, and the engines cannot tell the difference.
Wait, whether they are Rolls-Royce engines or GE engines?
Doesn't matter. They can't tell.
But surely there are chemical differences. I mean, you can't just swap a fossil fuel for something made of, like, plants and expect the exact same performance. Don't you have to change seals or gaskets or something?
Actually, you don't. And that is the engineering triumph of SAF.
Really? No modifications at all?
None. See, conventional jet fuel is just a specific mix of hydrocarbons. SAF is literally engineered to mimic that exact hydrocarbon chain almost perfectly.
Oh.
It has the same aromatics, the same density specifications.
Mm.
So unlike the early days of biodiesel in cars,
Oh, yeah, where people were risking clogged filters and needed new engine parts.
exactly, modern SAF is certified to be completely fungible with fossil kerosene.
Fungible, so it's basically a one-to-one replacement from the engine's perspective.
100%.
Okay, so the hardware doesn't need to change,
Yeah.
and that explains why adoption can happen right now in 2026, rather than, waiting for a completely new fleet to be built in 2040.
Precisely. The planes you have today work with the fuel of tomorrow.
But let's talk about where this stuff actually comes from, because the sources mention HEFA and synthetics. Can
Yeah.
we break that down? Because I assume we aren't just squeezing corn in a backyard somewhere.
Far from it. HEFA, which stands for hydroprocessed esters and fatty acids, is the dominant technology right now.
Okay, and what is that exactly?
This is your used cooking oil, animal fats, industrial grease. It's collected and refined into jet fuel.
Cooking oil into jet fuel.
Yeah. It's proven, it works flawlessly,
Mhm.
and it's what is actually powering most of these green flights today.
But there's a massive supply cap on that, right?
A huge one.
Because I remember reading that even if we collected every single drop of used cooking oil on Earth, it would only cover a tiny fraction of global aviation demand.
Exactly. You run out of French fry grease pretty quickly when you're talking about global flight routes.
Right.
And that bottleneck is exactly why the industry is pivoting so hard toward the second type.
The synthetics.
Yes. Synthetic SF. It's often called power-to-liquid, or e-fuels.
Okay, this is the part that felt a bit like sci-fi in the research.
It is basically reverse engineering fossil fuels.
How does that even work?
You take hydrogen, which you have to produce by electrolyzing water with renewable energy.
Okay, so green electricity to get hydrogen.
Right. And then you combine that hydrogen with carbon that you've captured directly from the atmosphere or from industrial exhaust.
Wait, so you are literally pulling carbon out of the air and turning it back into liquid fuel?
That is the promise. You synthesize them into liquid hydrocarbons.
That sounds incredible.
It is incredible. But, and this is a massive but, the energy required to do that is enormous.
Oh,
You need unbelievable amounts of green electricity just to make the hydrogen. And that is why the cost is so astronomically high. You aren't just drilling for oil and refining it. You are manufacturing fuel, molecule by molecule.
Which brings us perfectly to the physics problem we noted in the outline.
Ah, yes.
Because listeners are probably wondering, why go through all this trouble to make liquid fuel? Why aren't we just putting batteries in these jets?
It's the logical question.
Right. We have electric cars everywhere now. Why don't we have a battery-powered Gulfstream crossing the Atlantic?
It all comes down to one brutal number: energy density.
Energy density.
Yeah. Jet fuel, traditional kerosene, holds about 43 megajoules of energy per kilogram.
Okay.
It is incredibly potent stuff. It packs a huge punch for its weight.
And batteries.
Current lithium-ion tech is hovering around maybe 0.25 to 0.3 megajoules per kilogram.
Oh, wow.
Yeah. Even with the new solid-state batteries in development, we are nowhere near the energy density of liquid fuel. Not even close.
So the math just strictly doesn't work.
Not for long-haul flights. If you tried to electrify a transatlantic flight with today's battery tech, the battery itself would weigh more than the plane can actually lift.
You wouldn't even get off the tarmac.
Exactly. That is why SAF is the only viable option for long-range aviation for the foreseeable future. Liquid fuel is just too good at storing energy to give up.
So we are essentially stuck with liquid.
We are.
We can make it synthetically, yes, but as you said, it costs an absolute fortune. Let's really dig into that price tag.
Sure.
You mentioned a 3 to 5 times premium earlier.
Yes.
Now, in the corporate world, usually the CFO kills an idea like that immediately. They'd say, why pay $15 a gallon when we can just pay $3?
Of course they would.
So how is this being sustained? Why are they paying it?
Well, there are two main drivers. One is the corporate ESG mandate.
The environmental, social, and governance goal.
Right. Companies desperately need to show their investors that they are lowering emissions. But the more fascinating driver is what we call the stick approach.
The strong-arming we teased earlier.
Yes. The strong arming by infrastructure providers. This was that point about hangar space in the source material.
I found this absolutely fascinating because this is the FBOs, the fixed base operators, which are basically the private terminals at airports. They're the ones flexing their muscles here.
Correct. The FBOs are the gatekeepers. If you want to park your jet at a prime location, say Teterboro outside New York or Geneva or Farnborough near London.
Prime real estate.
Very prime. Space is incredibly tight. And these FBOs are under their own intense pressure to decarbonize their ground operations and their Scope 3 emissions.
So they are basically passing the buck to the tenants.
Effectively, yes. The sources detail a major shift happening right now. Securing a long-term lease in a premium hangar now often comes with a hard stipulation.
Which is?
You must commit to purchasing a certain percentage of your fuel as ASAF.
Wow. That changes the dynamic completely.
It really does.
It's not a polite, hey, please buy our green fuel. It's literally, if you don't buy the green fuel, you can go park in some secondary airfield 50 miles out of the city.
Exactly. It's a pure pay-to-play model. The fuel premium essentially becomes a hidden rent cost.
That is brilliant leverage.
It is. Because for these owners, time is their most valuable asset. They are not going to drive an extra hour through traffic just to save a few $1,000s on fuel.
Absolutely not. So the infrastructure owners are essentially regulating the market much faster than any government agency is.
In some ways, yes. They are moving the needle today. But the governments are catching up. We are actually seeing a rapid move from voluntary offsetting to mandatory blending mandates.
Let's clarify that, offsetting versus reduction. Because for years, the standard move was people would fly private, feel a bit guilty, and then pay some company to plant trees somewhere.
Right.
But the sources suggest that era of just planting trees is over.
It is largely viewed as completely insufficient now. The core problem with traditional offsets is that they are totally disconnected from the actual polluting activity.
You mean spatially disconnected?
Spatially and temporally. You burn carbon in the sky over the Atlantic today, and you just hope a sapling somewhere absorbs it over the next 20 years.
Right. It's a bit of a shell game.
Exactly. SAF, on the other hand, offers an actual life cycle reduction.
And the sources cite for that is an 80% reduction?
Yes.
But why 80%? I mean, if it's synthetic or made from plants, shouldn't it be 100% reduction?
That is a super common misconception.
Yeah.
Listeners need to understand that when you burn SAF, you are still emitting CO2 out of the back of the jet engine. The physics of combustion hasn't magically changed.
Okay, so if the plane is still emitting carbon, where does the reduction actually come from?
It comes from the fact that the carbon you are emitting during the flight was recently taken out of the atmosphere to make the fuel in the first place.
Oh, I get it. Whether by plants growing or by those direct air capture machines we talked about.
Right. So you are part of a very short-term carbon cycle. You are not drilling down and introducing new fossil carbon that was locked safely underground for millions of years.
I see. So it's totally circular. You borrow the carbon from the air, you burn it to fly, you return it to the air.
Exactly.
But then why is it only 80% and not a perfect 100%?
Because there is still energy used in the production process. The transport. The refining of that fuel.
Ah, the supply chain.
Right. Until the entire supply chain, the delivery trucks, the refineries, the cargo ships, is also running on zero carbon energy, you have that 20% gap.
That makes total sense. And honestly, that makes the accounting aspect of this absolutely crucial.
Crucial and very complicated.
Because if I'm a jet owner and I'm paying that massive 5x premium, I want to know for an absolute fact that I'm getting that specific batch of green fuel.
Right.
But the sources mentioned something called book and claim. And honestly, when I read that, it sounded a little bit like crypto.
It's highly similar in principle. Think about the regular electricity grid for a second.
Correct.
When you pay for a green energy plan at your house, the actual electrons coming into your toaster aren't necessarily piped directly from a wind turbine.
Right, they are just coming from the general grid.
Exactly. But you paid for the renewable input to be added to the grid somewhere on your behalf.
So book and claim works the same way for jet fuel?
Yes.
Yes.
If you are flying out of a small airport, in Bali, let's say, that doesn't have any physical SAF tanks yet,
Okay.
you can still pay the premium for VAF to be pumped into a commercial plane over in Los Angeles.
Wow. And I get the credit for the emissions reduction on my flight in Bali.
Exactly. You book the green fuel and you claim the environmental credit. This decouples the physical liquid from the financial transaction.
That solves a massive logistics problem.
Yeah, it really does. Because we physically cannot truck SAF to every single remote island or small airfield in the world right now.
Right. But obviously that system requires immense trust.
Immense trust and extremely rigorous auditing, which is exactly where those new transparency tools and blockchain ledgers mentioned in the report come into play.
So it effectively turns carbon reduction into a tradable commodity that is just attached to your travel profile.
Yes. And it allows the whole market to scale up financially without having to wait for physical infrastructure to reach every corner of the globe.
Incredible. Now, earlier we dismissed batteries completely for long-haul flights,
Right, the energy density issue.
but the outline does explicitly mention hybrid electric prototypes entering the market. Where do these fit into the picture if SAF is the king of the hill?
This is where we see the market start to bifurcate.
Okay, explain that.
For the mission profile of a heavy transatlantic flight, yes, it's SF all the way. But think about the short-haul luxury commute.
Like a 45-minute hop from the city center out to a coastal retreat.
Exactly. The classic helicopter replacement route. For trips under, say, 300, 400 miles, the energy density problem of batteries is actually manageable.
Oh, because the plane doesn't need to carry that much total energy anyway.
Right. So we are seeing electric vertical takeoff vehicles, or eVTOLs, and short-haul fixed-wing electric aircraft rapidly entering the testing phase now.
And they offer something that even SAF-powered planes can't. Right.
Silence. Total silence. No engine roar, no vibration.
Which is a profound luxury in itself.
Huge. So the true future of elite travel looks like a mix. You take a silent electric aircraft for the short hop from your office to the main airport, and then you transfer to a SAF-powered heavy jet for the ocean crossing.
But this introduces a totally new constraint, doesn't it? Route planning.
How so?
Well, we are used to the idea that a private jet provides total absolute freedom. The whole pitch is go anywhere, anytime.
Right.
But if you are now dependent on electric charging infrastructure for the short haul, or S availability for the long haul, or at least the booking claim network being recognized there, doesn't the map basically get smaller?
It definitely gets more complex. We are entering an era of logistical constraint for the ultra-wealthy.
Which is something they aren't used to.
Not at all. But if you are strictly committed to a zero-emission mandate, whether for personal branding or corporate roles, you literally might not be able to fly to certain remote destinations if the verified fuel supply chain doesn't extend there.
That is a profound shift. The infrastructure itself is beginning to draw the borders of where the elite can actually go.
It creates a tiered system of global travel.
Yeah.
The green corridors between major financial hubs, London, New York, Dubai, Singapore, they will be fully serviced.
Seamless travel.
Seamless. But the off-grid locations, they might become significantly harder to justify for the compliance-obsessed traveler.
So, bringing this all back to the central theme of the deep dive, we have this massive rebranding of what status means.
Yes.
We have a brilliant technological workaround with SAF to bypass the harsh limits of batteries.
Right.
And we have a financial model where the wealthy are essentially subsidizing the early development of this entire global supply chain.
That is exactly the economic reality of the situation.
Yeah.
And we should be really clear here. This is exactly how new technology often scales.
True.
The massive green premium is currently being absorbed by the only demographic on Earth that can afford to just ignore the price tag.
They are essentially the beta testers for the rest of us.
They are the early adopters who pay down the cost curve.
Just like Tesla.
Exactly like Tesla. They started with a six-figure roadster for the ultra-rich before making a mass-market Model 3. Private aviation is doing the exact same thing. They are proving the commercial viability of SAF.
So the hope is that as production ramps up to meet this luxury demand, the price will eventually fall enough to make it viable for regular commercial airlines.
That is the theory.
So in a very strange twist, the billionaire paying $20,000 extra for green fuel to fly to Davos might actually be helping to decarbonize the coach ticket I buy to visit my grandmother in 10 years.
That is the optimistic view, certainly.
And the cynical view.
The cynical view is that they are simply buying the right to keep flying their private jets while the rest of the world faces intense pressure to cut back on travel.
Fair point.
But regardless of their personal motives, the capital flow is very real. The massive investment in synthetic fuel plants is happening right now, specifically because there is a luxury market willing to pay 5 times the price of kerosene.
It's just a fascinating interplay of ego, economics, and engineering.
It really is.
Honestly, it seems like status is a more powerful renewable energy source than wind or solar could ever be.
It is certainly a powerful accelerant.
Yeah.
If you can make sustainability a genuine competitive advantage among the ultra-wealthy, you can move markets way faster than government regulation ever could.
Absolutely. Now, before we wrap up, I want to linger on that infrastructure point one last time, because for me, that was the most striking part of the research.
The FBO requirements.
Yeah. We've talked about the carrot of social status and the stick of hangar access.
Right.
But if this trend really accelerates and airports start mandating these fuel blends, not just for parking your plane, but just for landing there in the first
Which
place,
is entirely possible.
we are looking at a world where your fundamental ability to travel freely depends entirely on your carbon compliance.
It becomes your literal license to operate. In 2026, right now, it's basically just a luxury tax.
Right.
But by 2030, it might be the absolute baseline requirement for entry into major cities.
Which means the ultimate luxury of the future might not be the jet itself.
No.
It will be the verified proof that you didn't damage the planet by flying it.
A clean conscience really is becoming the most expensive accessory of all.
That is a hell of a takeaway to end on. We're going to leave it right there. Thanks for deep diving with us today into the incredibly expensive, highly complex world of green aviation.
It was a pleasure to be here.
And to you listening, the next time you see a contrail overhead, ask yourself, is that just water vapor? Or is it the exhaust of a rapidly changing economy? We will see you on the next deep dive.